Okay, today you want to carry out scientific investigation and write complete experimental report. You can refer to page 14. Okay, look at the figure 1.11 shows situation in playground. Okay, you can read the conversation below. Friends, look up there, the two swings are swinging at different speeds. Okay, right, probably due to the length of chain of the swings. Let us carry out scientific investigation using a simple pendulum to find out. So when there's a question arise, normally we want to find the answer. So this is one question that arises. What factor that cause the two swing to swing at different speeds? Okay, so we have the idea about the experiment. So to investigate the situation shown in the picture, so you want to carry out experiment 1.1. Inference. What is inference? Inference actually the early conclusion based on the situation given. Okay, normally it's based on the diagram or picture or situation given, not based on experiment, the inference. Okay, so in this one you can write down, so for this one, inference, a period of oscillation, we can use the swing because this one refer to the diagram is a swing. The period of oscillation of the swing depends on its length. So this one is accepted. Okay. Hypothesis, the longer the length of pendulum, the longer its period of oscillation. So now hypothesis is predicted result for the experiment to be carried out. So you cannot use the word swing anymore because this one is related to the experiment. Okay. To investigate relationship between, normally is manipulated variable and responding variable. So in this experiment, the manipulated variable length of pendulum L, period of oscillation T is the responding variable. Constant variable is mass of ball. Look at the apparatus required: retort stand, protractor, pendulum bob, stopwatch, meter rule, G-clamp. Materials are 100 cm of thread and 2 small pieces of wood. So you need to arrange all the apparatus to form like this. Okay. Okay. What you do, you carried out experiment. You must read through all the procedure carefully and then record all the readings in the table provided. What we need for this experiment is that we need a stopwatch. I use digital stopwatch. 2 pieces of wood. You can use coin, meter rule, thread, a bob, a steel bob, and this is a retort stem with clamp. Place the thread in between the 2 pieces of wood. Hold it tight, then clamp to the retort stand. So by using this method, it is easy for you all to adjust the length of pendulum just by pulling the thread. Okay, use ruler, measure length of pendulum. So we just pull from the top to adjust the length of the pendulum. To make it shorten, you pull it from the top. If you want to increase the length, just pull the bob down. Okay, use ruler and measure accurately from the clamp, from the point where you clamp the thread and the center of the bob. The first value of length that we are going to use is 20 centimeter. Okay, displace the bob to one side about angle 10 degrees and release the oscillate. Record the time taken for 20 complete oscillation. 1 complete oscillation is move to and fro once. Make sure you start the stopwatch simultaneously with the counting to prevent error due to random error. Okay. You can record the time taken in the table provided. Okay, the value of the time taken is 17.87. Repeat the step to get the second reading for length of pendulum 20 cm. Record the time taken for 20 complete oscillation. This one is to find average of time taken. Okay, record the time taken as 17.5. Okay, now increase the length of the pendulum to 30 cm. Use a meter rule to measure. Pull the bob down to increase the length of pendulum. Okay, you repeat the step. Now displace the bob to one side, release to oscillate. Measure time taken for 20 complete oscillation and record in the table. Okay, the first value that we get is 21.60. Okay, repeat the step to find the second reading, time taken for 20 oscillation for length of pendulum 30 cm. Okay, record the reading as 21.54. Okay, adjust the length of pendulum to 40 centimeter. Measure the time taken for 20 complete oscillation. And record the time taken as 24.34. Continue to find the second reading of time taken for length of pendulum 40 centimeter. And record the reading as 24.44. Okay, adjust the length of the pendulum to 50 centimeter. Repeat the same step to measure time taken for 20 complete oscillation. And you can record the first value of time taken as 28.00. Okay, repeat the same step of experiment to get the second reading of time taken for length of pendulum 50 cm. Okay, record the reading as 28.25. Adjust the length of pendulum to 60 centimeter. Repeat the same step to get the time taken for 20 oscillation. And you can record the first reading as 30.09. Okay, repeat the step to get the second reading of time taken for 20 complete oscillation for length of pendulum 60 cm. Record the time taken as 30.32. And now adjust the length to the length of 70 cm. Repeat the step to get time taken for 20 complete oscillation. Remember, the angle of oscillation must be small. Okay, record the time taken, 32.31. Okay, repeat the step to get the second reading of time taken for 20 complete oscillation for length of pendulum 70 cm. Make sure angle of oscillation is always smaller, about 10 degrees. Make sure the fan is off also at the same time to prevent air to affect the reading of the time taken. Okay, record the time taken as 32.87. Okay, from the experiment we have recorded all the data required. Okay, you can see we have T1 and T2 for different lengths of pendulum, 20 to 70 cm, and then you calculate the average by using the formula given above. Average is T1 plus T2 divided by 2, and then calculate for period of oscillation. Period of oscillation is time taken for one complete oscillation. Okay, so use the formula here, T average divided by 20, and then calculate for value of T squared. You just use calculator, square this value. Square the value of T to get T squared. The unit also becomes second squared. So now based on the table here, you need to make sure that you have a consistent readings in the table. Okay, for T1 and T2, we use a digital stopwatch. Accuracy is 0.01. Thus, you need to record the readings in 2 decimal places. Same as the average. Also must be 2 decimal places. And then T is the value that calculated through the formula T and T square. This one you can record from maybe 2 to 4 decimal places. Okay, so for t, you calculate, you have all this value. You see, if the first one you take as 2 decimal places, meaning the rest all must be 2 decimal places. So this one we call it consistent reading. And then same as t squared, you calculate. Here I write down in 3 decimal places, so all the readings are in 3 decimal places. So this one we call it consistency, yeah? Consistent in the readings. All column must be consistent, means same number of decimal places. Okay, next we have the data. We want to analyze data. To analyze data, you need to plot a graph of t against L and a graph of t squared against L in separate sheets of graph paper. Okay, and then you can answer the rest of the question. Okay, you want to plot a graph of t against L. Write that title above here. Okay, now we draw axis. Use pencil. I use a pen because I want to make it clearer for you all to see. I use maximum of the graph paper. Now you want to label the axis. You want to label, you look at the title, T against L, meaning y-axis must be T. Unit, write down label and unit, TS. And then for the x-axis, same thing, label, L unit centimeter. Okay, you label then L, x-axis, L unit centimeter. Okay, now we want to set the scale. Look at the value of t. The maximum is 1.63 for L, for t, maximum is 1.63, and then for L maximum is 70. So for t axis, I will use 2 larger square, 2 cm, 0.2. So it becomes 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8. Maximum is 1.6, already cover more than 5 larger square. And then for this one, 2 cm 10, 20, 30, 40, 50, 60, 70. Okay, now we want to transfer the points. Length 20, T 0.88. Be careful when you transfer, rate the scale correctly. Yes, we have a curved line. Okay, for this graph, T against L. Okay, now we want to draw for T squared against L. We have the x-axis is T squared unit second squared, and the x-axis here is L cm. Okay, can draw axis. Must start from 0, both axes. Don't jump to 20. For example, the x-axis, because data start from 20, you cannot just jump, must start from 0. And then the scale must be uniform. Okay. Best one, if cannot, you just balance the point above and below. You need to use a long ruler. I want to check balance or not. If I pass through this one. Okay, we have drawn the graph. So we can get the graph is a straight line pass through origin. Okay, let's check the next question. Okay, number 2, state the shape of the graph and relationship between variables in each graph. Determine gradient m of graph t squared against L. State the value of m in SI unit. And then 4t squared equals to 4 pi squared L over g, where g is Earth's gravitational acceleration. Relate gradient m to value of g, then determine the value of g in this experiment. Okay, for answer number 1, we have plotted the graph. Okay, this part for analysis of data. So we have part 2, based on the shape. So based on the graph of t against L, a curve graph with positive gradient shows that y is increases with L. Okay, and then for the second graph, based on the graph of t squared against L, a straight line passes through the origin, shows that t squared is directly proportional to L. Okay, so this is how you interpret the graph based on the graph, and then you state the relationship between responding variable and manipulated variable. Okay, number 3, determine the gradient m. Gradient m. Okay, what we do, we need to draw a triangle below the line. Just draw this one. Okay. And so we have the height is 1, 2, 3, 4, 5, so more than 4. Wait, 1, 2, 3, 4. Okay, minimum is 4 times 4. Okay, so the height delta t squared is equals to, here is 1.5, 1.50. So it's 1.50 minus 0. And then below here is 40. So it's 40. This one is delta L. 40 minus 0. So we get this one. Write the gradient. Remember the unit here is second squared. Here is cm. Thus it becomes, it's delta t squared divided by delta L. Thus equals to 1.50 minus 0 divided by 40 minus 0. 1.5 is second squared. 40 is cm. Okay, remember this part, cm you need to convert to SI unit. So divide by 100. Okay, so you have 1.5 second squared divided by 0.4 meter. 3.75 second squared meter to the power negative 1. Okay, so we write in SI unit, this one. And the answer here is at least 3 significant figures. So actually for the value of gradient, based on the graph that you draw, the answer, there must be range of answer. Okay? Because some students will use different points to calculate the gradient. So if your answer is still in the range, meaning your answer is correct. Okay? Number 4, given t squared is 4 pi square. T square equals to 4 pi square L divided by G. Okay? G is Earth's gravitational acceleration. So relate gradient M to value of G, then determine the value of G in the experiment. So if you look at the graph, the gradient of the graph here is T squared divided by L. So from here, I can write T squared divided by L equals to 4 pi square divided by G. Okay, so this one actually is the gradient. Thus M equals to 4 pi square divided by G. Okay, so we want to find G. G is 4 pi square divided by M. Thus it becomes 4 pi square divided by 3.75. Okay, remember the unit, second squared meter to the power negative 1. Okay, unit for the 3.75. Okay, so what we get for this one? Okay, so we get this and the answer. So normally we cannot get accurate answer, 9.81, because there's a lot of error occur during this experiment. So what conclusion can you make based on this one? Conclusion? To write conclusion, you go back to the hypothesis. So does the predicted result or hypothesis can be accepted or not? Okay, so based on this, you get t squared is directly proportional to L. Thus, we get when L increases, T increases. Thus, hypothesis is accepted. Okay.